Hello ladies and gentlemen, we're going to review all the content from our first unit here, this review. So we're going to start off with section A1 in the book. This is radicals and rational exponents. So first question, you have a power to a power. You need to multiply 3 times 1/2. Well, that's just 3 halves. 6 times 1/2 is y cubed. These are different bases, so we are finished. Okay, you can't combine x and y's if they have different bases. Second one. First, look for coefficients. 3 is out front. 3 times 1 is 3. Fine. Then I have a to the 2/3 times a to the 1/3. So we're going to do 2/3 plus 1/3 and get 3/3. 3/3 is 1 whole. You don't really need to write that. Same game with b's. B to the 3/4 and b to the 5/4. If you have 3/4 and you add 5/4, then you have 8/4, which is 2 whole. 3ab squared. Third one, you kind of have two parts. You've got a numerator that I'm going to simplify, and a reminder, to the 1/2 power is really a square root. So I know the square root of 64 is 8, and then I'm going to use my exponent rules. 6 times 1/2 is 3, and 8 times 1/2 is 4. So 8a cubed b to the 4th. Down here, that's a cube root, so the cube root of 8 is 2, and 3 times 1/3 is 1, and 6 times 1/3 is 2. But now I need to see if I can simplify what I've got, and I kind of have 3 problems, 1, 2, 3 that I have to talk about. 8 divided by 2 is 4. A cubed over a squared, one of them will cancel out, and you will have 2 in the top. 2 b's will cancel out, and you'll have 2 in the top. So 4a squared b squared is your answer. Last one, you have a 1/2 exponent, so I'm going to multiply 2 times 1/2 and get 1. I don't want to write that. 3 times 1/2, that's 3 halves. X to the 3 times 1/3 is 1. Again, don't need to write that. And 1/3 times 3 is 1. So x's are easy. X times x is x squared. But then you have to add 3 halves and 1 whole, which is 2 halves. So 3 halves plus 2 halves make 5 halves. Y to the 5 halves. X squared, y to the 5 halves. That's A1. Let's try some radicals. Well, that's exponents. Let's do some radicals in A1. This one, if I see the square root of 64, I know that's 8. But then, as a reminder, x, 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 y, y. If I say take the square root of that, I'm looking for pairs of 2 because it takes a number times itself to escape a square root. That's the opposite of squaring something. That means that for every 2 underneath, 1 can come out. So I'm going to have 1 x on the outside, 1 y on the outside, but there's still that 1 x that's trapped forever. So 8xy radical x. This problem can be done multiple ways. I'll tell you the easiest way to do it is to condense the fraction on the inside first. So since these are both 4th roots, you can rewrite this as 1/4 root. And the reason that helps you is you can simplify that fraction. 16 over 2 is 8. And b over b to the 5th is b to the 4th. So I'm going to take the 4th root of that. Makes it a lot easier to deal with. The 4th root of 8 is not a whole number, so I'm done with that. But the 4th root of b to the 4th is just b. So that's my best answer, the 4th root of 8 over 4. I'm going to factor 96. So this is the 5th root of, I'm going to draw this, it's a lot. So I'm going to factor 96 to help me with this one. 96 is 2 times 48, which is 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. And then x, 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 and y cubed isn't enough, so I'm not worried about it. Since it's a 5th root in this problem, I'm going to look for sets of 5. 1, 2, 3, 4, 5 2's. Okay, one's going to get out, and 5 x's, so one's going to get out. So I'm going to have 2x on the outside, times the 5th root of what's still in there, 3y cubed, 3y cubed. 2x to the 5th times the 5th root of 3y cubed. Last one, this one's kind of easy because you see it's a 4th power and it's a 4th root. That means what's going to survive here is the radicand. 562 is the answer. They're inverses, so they cancel each other out. So that's A1. Now let's talk. Our next page is A2, completely factor. When it says completely factor, you need to always remember to look for GCF. And this one is really easy to forget because these are both perfect cubes. So I'm going to factor out the 8, and I will be left with x cubed plus 216 divided by 8 is 27. And now what we have is another sum of cubes. If you don't remember sum of cubes, it's AB, A squared, AB, B squared. And then the way you remember the signs is SOAP, S-O, always positive. So the same sign, if this is positive, that'll be positive. The opposite sign, and then always positive is always positive. So we take the cube root of x cubed, x, the cube root of 27, 3, A, B, A squared, their product, AB, B squared, 9. 8's still up front. My signs are same, opposite, always positive. Same, opposite, always positive, completely factored. Ooh, miss again. Hey, we got it. Okay. So that's completely factored. If you don't have the GCF, you are not completely factored. Let's try another one. Oh my goodness. All right. Good thing about these problems is you don't have to think that's getting factored out. Is there any other GCF? So first, let's look at coefficients. 4 and 8 factor out of 4. X squared minus 2, like I said, we're factoring out the negative exponent. Okay. What else? 2x squared minus 5. How many do both of those have? This one has 3. This guy has 2. So I'm going to factor out 2 of them. That's my GCF. It's messy, but I don't really have to think about it for the rest of the problem. I'm going to think about what's left if I factor that out. So if I factor that out, factor out the 4, factor out the negative 1/2. I had 2 of these, but I need another one. So 2x squared minus 5 to the first. I can just write it like that. Plus 4 times what gives you 8? 2. This is where we've got negative exponents. So here's the deal. When you are factoring, you're really dividing this out. If you divide, this is the numerator and that is the denominator, you would subtract the exponents. So we're really doing 1/2 minus negative 1/2. 1/2 minus negative 1/2 is the same as adding. 1/2 plus 1/2 is 1 whole. So we're going to have x squared minus 2. 1/2 minus negative 1/2 is to the first, which I don't really need to write. And I already have these taken care of, so that's what I got. I don't need to worry about this. This isn't going to change. Whoa, let me undo that. Undo. This GCF is not going to change. So I'm just going to say, hey, I need you again. Great, that's not going to change. What I do have to simplify is on the inside. So on the inside, in red here, I have 2x squared minus 5, and I can distribute 2x squared minus 4. I can combine like terms. So this would be on the inside, 2x squared and 2x squared make 4x squared, and negative 5 and negative 4 make negative 9. Oh, wait a minute. That is dots. So this GCF doesn't change, but I can factor in red, and when I factor in red, I'm going to write it as all factors now. That's dots. The square root of 4x squared is 2x, the square root of 9 is 3, so 2x plus 3, 2x minus 3, and that is now completely factored. It's kind of crazy. Let's try another one. Let's see. In the numerator, I can factor out a 5x cubed, and I can factor out, it looks like a couple of those. So in the numerator, I'm going to factor out 5x cubed and x minus 3. This guy has 3, that guy has 2, so 2 of them. What's left? So maybe to help see what we've got. That's my GCF. Now, since we factored out 2 of these, and there's 3 here, I need another x minus 3. But then what else? I factored out that whole thing. So if that's my GCF, I just need a placeholder 1 there. So I think this one's not going to be so bad. 5x cubed, x minus 3 squared, and then on the top I also have x minus 4. So I've only looked at the top, but I do have a bottom of this fraction. The bottom of the fraction is x minus 3 to the 5th. So I've simplified the numerator. Now I have to address, like, can I cancel anything? And if you notice, these are the same. So if you have 2 of them on the top and 5 on the bottom, I can cross out those 2, and this will then be 3. So this is 5x cubed, x minus 4 over x minus 3 to the 3rd power. And that is my final answer. Right here, I have another negative exponent. So just like before, I'm just going to factor that term out. So x minus 1 to the negative 1/2. And do they have anything else in common? Looks like they have a couple x plus 2's in common. Then I have what's left on the inside. Well, again, I have an x plus 2, and I have, let me do that in red, it just bothers me. X plus 2 and plus, okay, 3 halves minus negative 1/2. So 3 halves minus negative 1/2 is the same as adding. That's going to be x minus 1 quantity squared, because 3 halves plus 1/2 is 4 halves. So I'm going to have to actually FOIL this out. That's a quantity squared. The GCF doesn't change, so this is fine. Well, let me get this out of the way. This is fine. We need to do it again. Okay. But I need to simplify this. So it's going to be x plus 2 plus. When you FOIL that out, x minus 1, you get x squared minus x plus 1. So this is x squared minus 2x plus 1. Got to be careful with that. People will just try and distribute exponents and it doesn't go well. GCF doesn't change. Does this simplify it all on the inside? I'm thinking it probably does. We got x squared, negative 2 and positive 1 make negative x, and 2 plus 1 make 3. So is that factorable? Does anything multiply to 3 and add to negative 1? I don't think so. So I think I'm finished, and I think that whole thing is my answer. So this is my answer to that question. It's a bit messy. You can rewrite that with parentheses, but it works out. That's A2. Let's try A3. So this is rational expressions. We're going to factor everything we can, and if any of the factors cancel out, great. So I'm going to factor out the numerator. There's no GCF, but that's dots. 4x plus 3, 4x minus 3. I'm also going to factor the denominator, and to do that, I'm going to split the middle. So I'm going to find numbers that multiply to 4 times negative 6. I need to find numbers that multiply to negative 24 and add to negative 5. So 4x squared, let's see, that'd be negative 8x and positive 3x. So we split the middle, and then it's factored by grouping. So the GCF of each half. The GCF of these two terms is 4x, and I'm left with x minus 2. The GCF of these two terms is 3, and I'm left with x minus 2. And then my factors are 4x plus 3, 4x plus 3, 4x plus 3. The other factor is x minus 2. So if anything goes away, great. It looks like that'll go away, and that's my answer. So 4x minus 3 over x minus 2 is your answer. When you have compound fractions, you need to make sure that you get a common denominator in each part of the fraction. So right here, I'm looking like this guy's an x minus 2, that guy's an x, he needs an x, so top and bottom. This guy needs an x minus 2, top and bottom, and that's a quantity, so be careful. In the numerator, I will have my x times x minus 2 is my denominator, and I have to simplify the top. So all I'm looking at is right here. X times 1 is x minus, you're distributing, so minus x plus 2. That's the top of the fraction. Okay, there's multiple parts to this thing. I'll get to the bottom in a second. So the bottom is 2x over x squared minus 4. I could probably factor that. Let's just factor it. That's dots. So let's factor it. X plus 2, x minus 2. Now I'm going to copy, change, flip. So I have a fraction over a fraction. So the numerator is going to stay the same. I'm going to take that, x, well, wait, hang on. I can simplify that. X minus x is just 2. So 2 over x times x minus 2 times, so it was, there's your numerator, copy, change to multiplication, and I'm going to flip this. X plus 2, x minus 2 over 2x, and then I can see if anything cancels. It looks like that's going to cancel, and that's going to cancel. So I have x plus 2 over x times x is x squared. Okay, I think we have some operations still. Multiplication, we got to factor everything. So we got to factor all 4 of those. I'm not going to split the middle for all these. I can do them in my head. You can work them out if you want, but I'm going to do them in my head. X plus 2, x minus 1. That's the first one. This is dots, x plus 3, x minus 3. Down here, things that multiply to negative 6 and add to negative 1 are negative 3 and positive 2. And then this guy, let's see. Since 2 is prime, it's got to be 2 and 1. And since 5 is prime, it's got to be 5 and 1. I just got to place them the right way. So what multiplies to negative 10 and adds to 3? 5 and negative 2. So I want a negative 2 and a positive 5. My outer terms will be negative 2 and my inner terms are positive 5. So 2x squared minus 2 plus 5 minus 5. Good. Anything cancel? Yes. Yes. And I feel like one other thing should cancel. Anything else cancel? Oh, this is a 1. That's a 1. That cancels. When you factor that, it's x plus 2, x minus 1. I think I might have been saying 2 when I wrote that. So that cancels. X plus 3 over 2x plus 5 is your final answer. Yeah, that should have been a 1. My bad. Let's factor this one now. I'm going to copy, change, flip, and factor in the same step. So this, when you factor that, you're going to end up with, I think it's going to be 3x and 2x, and then let's see. I want the outside to be negative 50, so plus 7 minus 5, 3x squared minus 15 plus 4. Yeah, that works. And now I'm flipping this, so 2x plus 1 is now on the top. Bottom left is dots, 2x plus 1, 2x minus 1. And then when you factor that, you're going to have, let's see, 3x and x. So let's see, I think I want 15 minus, no, maybe I want 6 and 7. So minus 2 plus 7. Yep, that'll do it. Now I cancel what I can. Yes, yes. And I have 2x minus 5 on the top and 2x minus 1 times x minus 2 on the bottom. So that's completely simplified. Copy, change, flip, cancel what you can. P5 is modeling. So we did a bunch of modeling problems. If it helps you, you got to remember that there's 1, 2, 3, 4, 5, 6 x's here, and then L and L. So 2 L's on the top and the bottom. So I'm going to think, first of all, I have fencing, that's perimeter. So perimeter in this problem would be 1, 2, 3, 4, 5. 6x plus 2 lengths equals 1,200 feet of fencing. Okay. I also know that area of this big rectangle would be x times L. But they want me to write an equation, a of x in terms of width. So a of x can only have x's in it. If any L's have got to go away. So L, I need a substitution for u. So I'm going to come over here and isolate L. So 2L equals subtract 6x, then divide negative 3x plus 1,200 divided by 2 is 600. So when I write my model, a of x, now I'm going to write it over here. A of x is, I know what x is, but now I know what L is as well. Negative 3x plus 600. So my actual model, if I distribute it, which is probably a good idea, a of x equals negative 3x squared plus 600x. So there's my model. Now what I need to do is use my model. Now most of the time we did this with Desmos, but you might not have Desmos. You won't have Desmos on the test. So we have to remember how to find the vertex of a quadratic. Let me just refresh your memory here. I know that it's a quadratic that opens down. Okay, I don't really care about the x-intercept. I care about the vertex. So to find the vertex, you need to remember that you find the axis of symmetry. So x equals the opposite of b. Oops, that's not a b. Opposite of b over 2a. And then you plug that in. So negative 600 over 2 times negative 3, negative 600 over negative 6 is 100. So the x-coordinate of the vertex is 100. I also need to find the y-coordinate of the vertex. And to do that, this isn't going to work. To find the y-coordinate of the vertex, you plug it in. So negative 3 times 100 squared plus 600 times 100. So I'll type that in. Maybe. This thing wants to be not weird. What the heck is going on here? Let me see if I can get this to work. Okay, well, tell you what, I've already plugged it in, and it comes out to 30,000. I'm having technical difficulties, and I don't feel like dealing with it. So that means the y-coordinate of the vertex is 30,000. What I need to do is now talk about what I found. My model has an input of x. So x is the width, a of x. My output is the area. So if I say, what is the maximum area? The maximum area is the maximum y value. The maximum y value will be 30,000 That's feet squared. The dimensions, well, I know the width is x, that's 100, but to figure out the length, you could do two things. You could do 30,000 divided by 100, which is probably the easiest, and you get 300, or you could plug it in up here where you know the length is. You could also do L equals -3 times 100 plus 600, -300, oh my goodness, that scared me, plus 600 is 300. So the width is 100 and the length is 300. That's modeling. That's a long process. You have a lot of examples for that. You probably want to go through a couple more. Home stretch, nonlinear inequalities. You need to isolate, well, get everything on one side. So I'm going to subtract 30. And now I'm going to factor. So I'm going to completely factor the left side. So I'm going to factor out a 5, x squared plus x minus 6. And now I'm going to factor that, which would be x plus 3, x minus 2. Okay? And my points of interest, my zeros, are -3 and +2. So I know that if I plug -3 in or +2 in, I will get 0 at the top. That's great, but I want to know when this thing is greater than 0. See how it says greater than 0? So I'm going to put those on my number line in order, and I'm going to first say, like, if I plugged in -3, -3 plus 3 would be 0, 0 times whatever is 0. Is 0 greater than or equal to 0? Yes, so that should be a closed circle. Same thing with 2. If you plug in 2, you get 0 and it works. Now I'm going to make a sign chart. So I'm going to pick a number that's way smaller than -3, like -10. And I'm going to plug it in right here. That'd be a negative, and -10 minus 2 would also be a negative. So I'd have a negative times a negative, and I'd get a positive. If I plug in a number between -3 and 2, like 0, 0 plus 3 is positive, 0 minus 2 is negative, and their product would be negative. Big number, positive, positive, and their product would be positive. So I have this interval. I know where everything's going to be positive and where everything's going to be negative, but I have to make sure I pick the right interval. I want to know where it's greater than 0, so I want the positive intervals. That's to the left and to the right. And now I need to write my answer in interval notation. So this interval is -infinity to -3, and -3 has a bracket, and infinity always is parentheses. Union, 2 with a bracket, to positive infinity. And that is my answer. That's the interval of x values that will give me that will solve this original inequality. So if I plug in anything in that interval, it'll be greater than 30, or the quadratic will be greater than 0. When it's a fraction, it's kind of the same game. You find your zeros, 2x equals 0, so you set the numerator equal to 0. That's when x equals 0. But you also have a rational, so you have to know when the denominator is 0 and say, well, wait a minute, you can't plug in, you can't set this equal to 0 because then you would divide by 0. So x cannot equal 4. When I draw my number line, I'm going to put a dot at 0, and I'm going to put a dot at 4. And 0 works because if you plug in 0, 0 divided by -4 is 0, and 0 is greater than or equal to 0. But 4 does not work. That's a vertical asymptote in the graph. The numbers that are greater than 0, well, we've got to make a sign chart. So we'll make a sign chart. We'll plug in a negative number. That'd be a negative in the top, divided by a negative -4 is also a negative. So it's the same game, but you're dividing instead of multiplying factors. If you plug in a small number like 1, you get a positive over 1 minus 4 is negative, so you get a negative. And a big number would be positive over a positive, so you get a positive interval. Again, I want the positive intervals, so the positive intervals are to the left and to the right. You just got to be careful. In interval notation, my answer would be -infinity to 0 with a bracket. However, 4 does not work, so it's in parentheses 4 to infinity. And that is your interval notation for that one. Last one, it says find the domain. So to find the domain, you need to remember that you're not able to take the square root of a negative. So you take the radicand and you say, hey radicand, when are you greater than or equal to 0? Now it's a nonlinear inequality, and if you factor that, you're going to get x minus 1 squared. This one's kind of interesting because there's only one critical point in here. That's a little light. The only critical point is at x equals 1, and it makes a true statement, so it is a closed circle. What's interesting is, if you're squaring something, it's a quantity squared. That will always be a positive. If you plug in a negative, A negative times a negative is a positive. If you plug in a positive times a positive is a positive. So actually in this problem, all of this interval is positive. And there's not a hole in the graph, which means the interval is all real numbers, which we write as negative infinity to positive infinity in parentheses. This is all real numbers work in this problem. You can't break that function. Last one, set the radicand greater than or equal to 0. There's our last bell. And set the numerator equal to 0 and say, hey, x can't be 6 because that breaks the function. So we have to plug in positives to the square roots because you can't square root a negative, and we can't divide by 0. So x is greater than or equal to 3, and x does not equal 6. So 3 and 6. 3 works. You can take the square root of 0. 3 works. 6 does not work. That's an open circle. And the numbers that are greater than 3 are to the right. So it's going to look like that. I just have to write my answer in interval notation. 3 to 6. Union. 6 to infinity. Be careful with this 6 because it is an open circle. 3 is a bracket because it works. So that's it. If you guys can do this crash course, you're going to be in pretty good shape on the test. So good luck.